Example 7.12. An AC circuit contains a 20 millihenry inductor and 50 microfarad capacitor with an initial charge of 10 millicoulomb. The resistance of the circuit is negligible. Let the instant the circuit is closed be t equal to 0. A. What is the total energy stored initially? Is it conserved during LC oscillations? B. What is the natural frequency of the circuit? C. At what time is the energy stored? 1. Completely electrical, it implies stored in the capacitor. And 2. Completely magnetic, it implies stored in the inductor. D. At what time is the total energy shared equally between the inductor and the capacitor? E. If the resistor is inserted in the circuit, how much energy is eventually dissipated as heat? Okay. Now see, easy one but somewhat lengthy. Okay. See, inductor, that is with inductance 20 millihenry, so that is 20 into 10 raised to minus 3 henry, and capacitor, that is with capacitance 50 microfarad, so that is 50 into 10 raised to minus 6 farad. Now Qm, that is given to you, that is 10 millicoulomb, so 10 into 10 raised to minus 3 coulomb. So question A. Now initially the total energy. So total energy stored initially means at time t equal to 0, that is the electric energy stored in the capacitor. So that is Qm square by 2C. Qm, that is 10 into 10 raised to minus 3. C, that is 50 into 10 raised to minus 6. All this one, you will get energy. And this energy will be conserved. We discussed in the theory. Okay. Then question B. The natural frequency of the circuit, that is 1 upon 2 pi root LC, substitute L equal to 20 into 10 raised to minus 3, and C, that is 50 into 10 raised to minus 6. And solve it, you will get natural frequency of the circuit. Then after C, at what time is the energy stored is completely electrical, and second completely magnetic. Now see, electric energy at any time t, that is given by Qm square by 2C cos square omega t. So when the value of cos square omega t, that is equal to 1, then the total energy that will be stored in the form of electric energy. So cos square omega t, that will be equal to 1 when omega t, that is equal to n pi, where n, that is 1, 2, 3 and so on. So for omega t equal to n pi, your cos square omega t, that will be equal to 1, and u, that will be equal to ue. Total energy, that will be equal to electric energy, or we can say total energy that is in the form of electric energy. Now omega, that is 2 pi by capital T into small t, that is n pi, pi cancel. So small t, that is equal to n t by 2. So substitute the value of n, 1, 2, 3, 4. It implies that at time small t equal to capital T by 2, capital T, 3 capital T by 2, 2t, at these time, the total energy in the circuit, that will be in the form of electric energy. Then after, at what time the total energy is in the form of magnetic energy, that we have to calculate. So magnetic energy at any instant, that is Qm square by 2C, that is sine square omega t. So here when sine square omega t, that is equal to 1, then total energy, that will be in the form of magnetic energy. and that is when omega t, that is 2n minus 1 pi by 2, because sine pi by 2, sine 3 pi by 2, sine 5 pi by 2, sine 7 pi by 2 all give you the value 1 or minus 1, and square of it will give you resultant 1. So for omega t equal to 2n minus 1 into pi by 2, where n equal to 1, 2, 3, your total energy in the circuit will be in the form of magnetic energy. Now, omega, that is 2 pi by t into small t, 2n minus 1 pi by t, pi cancel, so small t, that is 2n minus 1 capital T by 4. So small t equal to t by 4, 3t by 4, 5t by 4 means at this time, means at time t by 4, 3t by 4, 5t by 4, the total energy in the circuit, that is in the form of magnetic energy. Clear? Then question D. At what time is the total energy shared equally between the inductor and the capacitor? Shared equally, it implies that the electric energy and magnetic energy, that is same one. So at any instant, we can write electric energy, that is Qm square by 2c cos square omega t, and magnetic energy Qm square by 2c sin square omega t, and compare these two. So cos omega t equal to sin omega t, and that is possible only when omega t equal to pi by 4. Again substitute omega, that is 2 pi by t. So pi cancel. Therefore, small t, that is equal to t by 8. It implies that here at t by 8, 3t by 8, 5t by 8, at this time, your electric energy, that will be equal to magnetic energy. Then, if a resistor is inserted in the circuit, how much energy is eventually dissipated as its entire energy? If resistor is connected, total energy will be dissipated in the form of heat after some time. Clear to all of you?